Hi class, let's take a look at problem 4 and then notice that we have the same situation that we did on the previous ones. One of them is going to be the intersection and then another one is going to be the union from the statements. And actually these two are pretty much solved. So let me actually graph the first one. In this case, x is less than 3. And this is so that we can dissect both of the solutions. So this is 0, 1, 2, 3, and I'm just going to put as a reference 4, 1, 2, 3, 4. And x is less than 3 actually means all the values to the left of, well, in this case, all the values to the left of 3, all the way to the negative infinity. And then for the absolute value of x less than or equal to 4, in this case, we can translate this inequality and notice that it represents all the distances that are less than or equal to 4. So technically, you could write it as x is less than or equal to 4 and greater than or equal to negative 4. So the graph of this one, not to scale, we would have 0. This is technically 3, 4, and negative 4. So for this one, we would have all the actual values that are in between. So we're including the boundary, so negative 4 and 4, and we're talking about all the values in here. And this particular statement represents the intersection. So notice that you don't have any values to the left of negative 4. And in that case, they're intersecting. Let me make it a little bit thinner. From, well, technically including negative 4 up until here. So they're intersecting at a value less than 3. So we're just looking at these values and not including 3. Even though this one does have it, this one doesn't have it. So they're not shared values. So our solution for the intersection, and let me write it here, it's going to be all the x is less than 3 and greater than or equal to negative 4. That represents from here up until less than 3. The graph and let me put 0, 1, 2, 3, 4, and then negative 4. So we're not including 3, open circle, but we're including negative 4 and every value in between. Once again, they're sharing 4, but they don't share 3. And then the last one would be the interval notation. So our interval notation is going to have negative 4, but it's not going to contain 3. That's actually it for this one. We'll take a look at the union. And let me just take another look on this one. So including the edges and not including, so from 4 to not including 3. And that would be fine. Okay. Now, the last portion is going to be the union. So when we look at the union, and let me use a different color, we're technically putting this solution along with this one and no repeats. So technically, as you merge both of these, it's going to have us an upper bound 4 because that's the maximum that this one reaches. And then because this one goes all the way to the left, it goes to the negative infinity. So our solution for the union, in this case, let me write it here. So our solution is going to be x is less than or equal to 4. The graph it's going to have all values 0, 1, 2, 3, 4. And close circle there all the way to the negative infinity. Interval notation. Or interval notation, it's going to have all values from negative infinity to the values of 4 with a bracket. And that's it for this one. So let me take another look. As we merge these together, this one goes to the left. Even though this one doesn't have it, we're including it. That's here. All the way to the maximum value would be 4. That's it for the union.